Welcome. Today, we'll solve the equation here in detail and reference the unit circle. Don't forget to subscribe for more math content. To eliminate the square root, we'll square both sides of the equation, so we have the square of the root of sine equaling 0 squared. Squaring a square root cancels it out, and squaring 0 still gives 0. So, we have sine of x equals 0. Now, let's use the unit circle. On the unit circle, the sine value represents the y-coordinate of a point where the terminal side of an angle intersects the circle. The sine function is 0 when this y-coordinate is 0, which occurs at the angles 0 and pi radians. In the picture the angles are in blue and the sine function values are in yellow. We discovered that the sine function is 0 at angles of 0 and pi radians. Now, we want to find all the other angles where the sine function is also 0. To do this, we can take advantage of the sine function's periodic property, which means its values repeat in a regular pattern over specific intervals. In this case, the sine function repeats its values every 2 pi radians. So, after every 2 pi radians, the sine function will have the same value as it did at the starting angle. Since we know the sine function is 0 at both 0 and pi radians, we can add or subtract multiples of 2 pi radians to these angles to find all the other angles where the sine function is 0. In the picture, if we begin at the angle 0, we make a full circle and come back to that point where y equals 0 again. In this case, the sine function repeats its values every 2 pi radians. So, after every 2 pi radians, the sine function will have the same value as it did at the starting angle. Since we know the sine function is 0 at both 0 and pi radians, we can add or subtract multiples of 2 pi radians to these angles to find all the other angles where the sine function is 0. However, there is a more efficient way to represent these angles. We can multiply any integer, positive, negative, or 0, by pi, and we will get an angle where the sine function is 0. This is because, when we multiply integers by pi, we cover both 0 and pi radians as well as their repetitions at intervals of 2 pi radians. In summary, to find all angles where the sine function is 0, we can use the general formula. Here, n represents any integer, whole number, value, including positive, negative, and 0. This formula includes both 0 and pi radians and their periodic repetitions, capturing all the angles where the sine function is 0. Let's illustrate the last part with some specific calculations using the general formula. X equals n pi. When n equals 0. Sine of 0 times pi equals sine of 0 equals 0. At this angle, the sine function is 0. When n equals minus 1. Sine of minus 1 times pi equals sine of minus pi equals 0. At this angle, the sine function is also 0. When n equals 1. Sine of 1 times pi equals sine of pi equals 0. At this angle, the sine function is also 0. These examples demonstrate that the sine function is 0 for all integer multiples of pi. Sine of n pi equals 0. No matter the integer value of n, positive, negative, or 0, the sine function will be 0 at the angles given by. In summary, we can use the general formula.